Hey everybody, this is Jim Neeb from Jim Neeb Woodworks. Today I'm going to be testing some new control hardware and software on my AVID CNC. Most of you know a few months ago AVID announced they were switching from Mach 4 and the ESS Smooth Stepper as the control software and hardware for their machines over to Centroid's Acorn board and CNC12 software. I wanted to stay up with what they're doing because, they're going to be introducing new things like possibly ATCs or other things in the future. So I wanted to, stay with their controls so that I could upgrade to the new accessories that they're shipping. The other thing is that Mach 4, it has a lot of good features, but it has a few downsides, and a lot of people have been complaining about. I've seen in the forums, and I think this is probably the primary driver why AVID has switched, is that Mach 4 had a tendency to just do funny things like just stop or not detect a probe event and keep going and crush the probe or something. It was a good hobby system, but for people that really need to count on their machine, it had some rough edges there, and it had a pretty gross lack of documentation as well. So, I thought I would give it a shot because I wanted to get by some of that, and I like to try new things too. The other thing is AVID is offering this kind of in two flavors. One is a new control box that will work with your stepper system. So if you had the Nema 23 or 34 steppers on your system, you can just get the control box and software and upgrade. But they're also offering, for the first time, servo motors, the ClearPath servos. So those theoretically offer higher speeds, but also they have some built-in, the controllers are built in, and they have some built-in smoothing algorithms where they can theoretically reduce your vibration even more. So, and besides that, the Centroid controller itself, the CNC12 software, has a lot more smoothing parameters built in there where you can do S-curves, all kinds of little tweaks you can make. Whereas on Mach 4, you basically had your speed you could adjust and your acceleration. And granted, if you turn your acceleration down far enough, you can cut your vibrations out, but you also sacrifice a lot of runtime performance, where in some cases, to get a really clean laser image, you could end up adding 40 or 50% to the execution time of your G-code file. So performance was achievable in the vibration department, but it always came at the cost of pretty high cost of runtime. Whereas with all these extra parameters, I've been told that the CNC12 software can run smoother but not sacrifice so much time. So that's my goal, is to test that out here. I got the full servo upgrade and stuff is what I bought, but a lot of people started asking me as soon as AVID came out with, pretty soon after their announcement basically, hey, should I upgrade to just the controller with my steppers, or should I spend the extra money for the servos? And I said, well, I don't know. I don't know what the difference is. So I asked AVID if I could get a loaner controller just for the stepper motors so I could do some testing. And then I'm going to ship that back, and then I'm going to install the one I bought that has the controller and the servos, and I'll do some testing there. So I'll be able to, my goal here is to help people decide if they want to upgrade at all, if they want to upgrade to just the stepper kit, or if they want to do the full-blown deal and go all the way. So this is kind of a AVID CNC Mach 4 comparing to AVID CNC with the Centroid, and the goal is basically to help people decide if they want to convert or not into which one, and what you might be able to expect. So I'm going to do a pretty quick performance analysis on this. Really, I'm not going to go into in-depth on the software. I'm just going to do some high-level tour through the CNC12 software and the hardware, and kind of the difference in architecture between Centroid and Mach 4, just to kind of give a high-level view of everything. And then I'm going to convert everything over, and I'll be doing more videos about fine-tuning laser performance and other things on Centroid. So what I'm going to try to do, I've written a couple G-code files that are kind of worst case for laser performance, and a couple, I've got one that really does some fine fonts. It's kind of a laser engraving file, and that's always been a really good one to shake up the system as far as vibration goes. I've got one that we'll look at the laser burns and see how sharp the corners are and how much vibration is actually there in the image. And then I ran a 3D carving file too. I picked out a section of a bigger 3D carving that I've done in the past that does some really rapid plunges. So it's kind of a worst case for all three axes running together. And my goal is to see how smooth is it, how smooth does it run relative to Mach 4, and how fast does it run. So smoothness without knowing how long the file runs is kind of useless. So I'm just trying to measure those smoothness and speed on this. And like I said, I'll give you a high level overview of things. I'm going to go over the pendant, that this is an option that you can get with this system too. It's pretty nice. And that's it. So hopefully enjoy this. Feel free to put questions down below in the comments section. I always answer them pretty quickly, and this should be fun. I'm kind of excited about this. As the biggest upgrade I've done to my CNC for quite a while, and it's hardware and software, so there's a lot of things to look into and learn here. All right, let's take a look at the hardware. So there's two things mainly that get changed out. First, you have the control box, obviously, because that has the actual Acorn board and stepper drivers and everything in it. And then there's a new touch, it's basically a ToolSetter feature. And then a real minor part of it is up on the gantry, they have some extra plates to let the x-axis come out a little bit farther on whichever side you've installed this touch plate. And the reason is they want to try to get the spindle to the center of this. And under with the normal stop bumper that you can see here, that was a little bit limited. I did not install this because, again, this one is temporary. I'm going to the servo system, which has different hardware yet. So I could get it to the edge of this well enough to work, so I didn't bother installing that new bumper plate. But the purpose of this tool setter is, well, it's really just the same as any tool setter, but the cool thing is it's out of the way. If you can see this, it's on the very rightmost edge of my boundary, and then in the front it doesn't really extend into this boundary. It does just it doesn't, because it's to the right of it, so it doesn't sacrifice any area of your working tabletop area, but it's in a fixed position. And I'm going to go over that a little bit later, but this really is nice. It sets you up for ATC, but it also really saves time with manual tool changes. So there's a little bit of change of your normal workflow with this, but in my opinion, this is a really slick addition. And once you understand how it works, which I'm going to try to explain, you'll see that, I think you'll agree that it's a pretty nice addition. So let's take a look at the hardware down here. I've got the box upside down just because I wanted the connections over here, but unfortunately for me, the way AVID laid this out is they put the connections on the left side of the box if it's right side up, and I didn't want it there, so I just set it on this box. Like I said, I'm just doing some testing here, and then I'm going to take it out. So what you got here is, if you remember, the ESS was a card more like the size of this little board, and it didn't have a breakout board of its own. It was really meant to be a plug-in, so AVID made a larger breakout board, the CRP, what was it, 860 or 850, I don't remember the number off the top of my head, but it plugged into that. This whole thing here is the Acorn board from Centrioid, and so it's built and formatted like a breakout board already. It's got all the IOs with nice screw terminals, and these actually the connectors pop out. So very convenient to hook up to. However, they've also made it easy to embed. So if you see this connector, this is a DB25 ribbon cable connector. So all your IOs that are out here and easy to wire to are also replicated on this, and that's what AVID uses. So this comes down to what they call an interface board down here. So this is essentially how they consolidate a lot of their wiring and make the wiring inside the box more simple, easier to build in the first place, and more reliable and all that. So everything else in here is pretty much the same. You got a couple of power supplies, 48 volt supplies to power your motors. You got all of your stepper drivers down here, and so for basically your controls come through the DB29 of the Acorn board down to this interface board, and then the interface board wires out to your panel connections out here, as well as the stepper drivers down here. We got a few power supplies and a contactor in here for disconnecting power in the motors under emergency. One thing to point out here is this is the it's a computer board. It's running, I believe, like a 4-core ARM CPU. I haven't looked at this for a while, so I don't remember exactly what it was. This is a full computer here, whereas the Smooth Stepper had a microcontroller and an FPGA, and all the path management of the tool path management was done. In this system, this computer is running the trajectory planner and everything. So your smoothing and stuff is done here, and well, sorry, the smoothing is actually done up there, but any kind of planning for all the access controls and stuff is actually done down here. So I'll go over that a little bit later, how the architecture looks different. But this is it's a very reliable system. If you go look out on the internet for people who have used these, they basically just run. Centroid has been making CNCs for 20 or 30 years, I think, something like that. They've been around a long time. So they're and they build their own CNCs, and they do a lot of retrofits of other CNCs. So they got a lot of experience with different things, and so running. One thing everybody says about these is they're just super stable. They don't do weird things or glitch and stuff like that. So you can see this box is pretty tidy. It's wired nice, just like the other stuff AVID does. They still use a kind of a panel board here for a lot of the sensors. So if I go to the other side here, this basically looks like the box used to. You got a bunch of your sensor connections, you got your motors down the bottom, and then you got some new ones here, extra auxiliaries, and I'll go over that. But at a high level, basically you've got your laser output that'll go to your laser box, and if you notice, there's no relays in here, the big power relays that used to be in the old controller. So what AVID did was, this time they made a relay connection. Back here there's I don't know if you can't really see it, but there's a special connector to go to a relay module. So they're selling a separate relay module that's configurable for voltage and stuff like that. So it's kind of nice. It doesn't clutter up this box. You could theoretically use that for other things besides just a relay module. So they're trying to make this more modular in that respect. So that's kind of it. The upgrade is really quick for just the stepper setup. I mean, you're basically going to replace this box. You're going to install that ToolSetter and a couple of plates up here. I think that all took me, maybe half hour to an hour from scratch. It's not a big deal. My laser setup here is a total mess because mine's a prototype and I hand wired a lot of the stuff. So ignore that. That's nothing that you'll get from AVID like that. All right, let's talk about system architecture a little bit, because this is kind of interesting. It's not super important for somebody who doesn't want to know the details, but some people like to dig in a little bit. So if we look at the most of the CNC systems out there that are for like a CNC router, generally you're going to have a PC, you know, running Windows or something. And it's going to, and so that's kind of the high end, that's the user interface is in here. So in Mach 4, with Mach 4, that's running Mach 4 with the graphical interface where you interact, load programs, run them, jog, all that stuff. And then down on the other end is some kind of PCB. The ESS is one example, and the Acorn is another. So this has all your I/O. So all your motor connections, your relay drivers, your sensor inputs, all of that stuff is there. You know, your PWM signal for maybe a spindle or a laser, all that stuff is coming out of here. So this is down in your machine, making a low-level physical electrical connections, and this is your high-level, you know, where your person is running the machine. And that's always going to be there in any of these systems, but how the work is divided up between these is different. So in Mach 4, the trajectory planner and really everything is up in Mach 4 running on the PC. And then there's an Ethernet line going down to the ESS smooth stepper, and then basically just sending simple commands down, and this runs it. This doesn't, other than there's the ESS has a few laser controls, but any of the laser stuff is still really done up here in the ESS plugin. So if you think about like laser rastering on an ESS, that's taken over by ES and doesn't really have anything to do with Mach 4, but that's just the little plug-in that's running in Windows. It's really nothing going on down here, because really this board is just following commands. So now if we look at, and that was the ESS, so now if we look at Acorn, it's more heavily loaded down to this board, and this side is a little less burdened, I should say, with things. So down here we actually have a computer. That's the board I just pointed out on the hardware. It's got its own, you know, it's got, I don't know, 16 gig of memory or something, and it's running a full operating system, and I think it's like a Snapdragon with it's ARM core of some sort. So this actually runs the trajectory planner here, and it can do a lot of other things. And so what's up here on the UI isn't doing the control. This actually can have your G code and run it down here. So that has disadvantages in that this has to have enough power, and you can't just go buy a PC with a lot more CPU power to do these things. But the advantage of it is this can really be locked down and controlled. One of the big problems with Windows is people load virus scanners, they get system updates, they have Wi-Fi running, so there's a lot of stuff going on here, and I guarantee just about everybody's CNC computer is running something different than the next guy's. So this is a very uncontrolled environment, which makes it very hard to make a CNC system that runs consistently. It's not impossible, but it's just easier when this software package here is really locked down and only controlled by the supplier, and you don't have people running Space Invaders on it or something like that in the background while your CNC job is running. So this is how, you know, the split between Acorn and CNC12. We'll go over that in a little more detail. But so this is more driving the interface. It's the user interface to do things. It's where all your setting and configuration is done. But that takes that information and runs it down here. So all the runtime stuff that's running at high speed and is down on this computer. And that's why there's really I should note, there's no real simulation environment for this, because without this CPU board, you can't run the software. So it's unlike Mach 4 where you could run it in your house just on a PC to debug software and stuff. You can't do that. I'm looking into what I would need to put in my house to do that, but I think I have to buy an Acorn board, or at least this this little CPU board at a minimum to do that, but most people won't want to do that anyway. So that's kind of the difference is, again, Centroid's running the real runtime operations down here instead of up on the computer. But other than that, they're both, you know, it's a software package here and it's a hardware package here, and Ethernet in between. That part is essentially the same between both of them. So I want to talk about, like, why did AVID put this ToolSetter in here? Well, one obvious answer is they've already mentioned on some of their forums they're working on an ATC set. And with an ATC, you need some way to measure each tool relative to each other so you can automatically switch tools without human intervention to measure the tool length. But they've also made this very nice for doing manual tool changes. So before, if you think about it in Mach 4, if you went into Mach 4, it had the ability to have a tool length. So you had, just like most CNC machines all have these kind of same features, right? You home to some corner on the machine, so you got machine XYZ 0, and that's your physical coordinate system for your machine, and it doesn't change. It just, every time you home, it gets reestablished. Then you have work coordinate systems, so WCS, you had, you know, G54 through G59, and then you have some extended ones that, if you need them, where you could say, okay, I want to call this point XY0 and some Z height, right? And then maybe you got some fixture thing over there and you have another coordinate system. And then that was established with the touch plate. But in between that, which we didn't really use in Mach 4 much, was the fact that you can have a tool length for every single tool. And so when you switch from one tool to the other, you can have that difference from one tool to the other accounted for and not have to remeasure everything else. But we didn't really use that in Mach 4 unless you went and installed your own ATC and stuff. In that case, you had to. But if you were just putting something down here and you wanted to cut something on this, after you homed, you would come over and put your touch plate on here, put your magnet on, and you come over here and do a probing. You might do a XYZ probe with the touch plate, you know, in the corner. You might just do Z and then go manually set it, but you never measured the tool height. And what happened in the background is basically our tool heights were always set to 0, and then the work coordinate system just got this height, right? And what that was the top of the workpiece, or maybe it was the top of your spoil board. It didn't really matter. It was some reference point for that work coordinate system. And then, of course, whether you were referencing the top of your workpiece or the bottom of your workpiece, i.e. the top of the spoil board, you also had to do that in Fusion 360, or you had to indicate in those tools when you're generating the toolpath, well, is my reference point here, or is it down here? And then when you switch the tool, you would do an M6 and you manually changed your tool, and then you come back and you have to drag your touch plate out, and at a minimum you'd have to redo Z, right? And so if you had a tool job or a tool path that had 5 tools in it, you had to drag your touch plate out in the middle of your job and retouch. So what AVID did was they said, well, let's use the tool height because we're going to need to for ATCs anyway, but why not just build the system in for manual tool changes? Because then if you think about it, I only have to measure this reference surface once, as long as I have a tool number or a tool length value for every tool. I can take that number and add it to some offset from the table. So what they do is we still home the system like always. So XY is 0 setup. But then when you do a tool change, it comes over here and touches off this, and it gets a measurement off this switch for that tool. So maybe you say they've got a nice manual tool change utility, and you hit it and it says what tool do you want, and you put in tool 3, and then it'll move over here and stop, and it'll say install tool 3. So you manually put that in the chuck and you say okay, and it comes down and it measures it. Well, that's not useful by itself, but when you set the machine up, there's one calibration that you do, and that measures this relative to your surface here. So you only have to do that once, and then obviously if you change your spoil board or move the tool setter around, then you'll have to recalibrate. But it's creating a delta in the software, a delta measurement from here to here. And so once that's established, you only need, like I said, you only need to run it once at the beginning of your setup. Now when you touch that off, you've got all the information so that when the system is done probing here, it actually sets the bottom of the tool, your Z0, to be this point. So now I've got, and every time it switches a new tool, it resets that to this point. So the only thing we need now for our work coordinate system is to know the difference between the top of the spoil board and the top of the workpiece, if we're using the top of the workpiece. Now if we're using the bottom of the workpiece or the spoil board top, well boom, we're already there. We've already got that number. But sometimes you have a spoil board on top. Like for me, I never want to cut into my spoil board, so I'll put down a sacrificial spoil board sometimes. Like if I need to cut through this, I'll do this and have a sacrificial piece here. So in that case, you would actually, the bottom of your workpiece would be the top of the sacrificial piece. So you would put your touch plate on here, and you can use any tool, it doesn't matter. That's the cool thing about this is, like I could even use this dowel pin, touch off on this, and it will save that number. And the number, if you look at it, it'll say, in this case, it would be a 1/4 inch, because that's the thickness of this. If I did it up here, it would be 1.25 inches, because this is a 1 inch MDF and a 1/4 inch MDF. So it's just storing the material thickness or the work surface delta from the top of the spoil board. So, and it keeps all those numbers separate, so it is going to automatically add them back together. So since, you know, if you're using 5 tools on this one piece, that portion of it's not changing, it's just the tool height. So basically, you'll take your one tool, you'll put this on here, and you'll measure your work surface, do that. And now every time you do a tool swap, you just do a manual tool change in it. You still have to, you know, manually put this tool in the collet, but once you do, it's going to come over here and measure it, and all the other math it takes care of. So you only literally need to use this once per job. And if you're somebody that's doing all your work off of this, for example, you actually use your spoil board as your work surface, so you're always referencing the bottom of your tool workpiece, then you never have to use this, because the calibration will take care of getting this, and then, you know, the tool measurement will be made here all the time. The nice thing about this is that's exactly how it'll work with the ATC system, so all the measurement and everything is all, you know, that's the same process. So if you ever want to upgrade, you'll already know exactly what you need to do there, and you know, your workflow won't be any different really for ATC versus manual. But all right, let's take a look at the optional pendant that AVID is selling. This is actually just a product Centroid has sold for years, but AVID is selling it as an option now for these. And I've never been a pendant guy. I've always used these little cheap wireless keyboards. The thing I really liked about these was I could use 2 thumbs and I could jog X and Y at the same time, and then I could use my control and shift buttons to alter those, so like I could fast jog or incremental jog, and I had like unlimited number of hotkeys I could make with this. So I really like this. So I've always been skeptical of pendants, and asked people when they had them multiple times, like, well, what can you do with this that I can't do with this? So I'm trying with this. I want to kind of say what's good and bad. So again, this has, you know, many macros I can write for it. And to me, the jogging is just a little more intuitive because of the, you know, layout of this. It's almost more like a joystick control or something. The way this works and is you can only do one axis at a time, which is not a limitation of the Pendant really, because Centroid only lets you jog on the screen at one axis at a time. You can't do two axes. I kind of wish you could, but I'm starting to get used to this now, and I honestly don't really miss it now after a few days. You pick your axis on here, and then you can pick your speed, so 1x, 10x, or 100x. So if I pick the fast speed, I can move it really fast. And you gotta, one warning is, when you got it on the Z, don't use the high speed at all, because it's way too fast. Now you can, and I should mention this, every single setting in the software you can change. I mean, it's very flexible, but the default speed here, the 100x speed is great for X and Y, but for Z, if you forget which direction is down or up and you turn that a little bit too quick, you're gonna plunge right into your material or something. So I always try to make sure I'm on 10x, because even at 10x, I got this dial, I can move it pretty fast. And then at 1x, you can really move it slowly. And then you still have your regular jog buttons. You got feed hold, you got cycle start, cycle stop. One thing you will notice on Centroid is that you're hitting cycle start a lot. There are a lot of prompts in the software to ask you to do things like, when you want to home the system, for example, it's going to prompt you to say, well, do you want to jog over there first to make the homing quicker, right? So yes or no, so basically it'll stop and wait for you to hit cycle start again. So you kind of got to get in the mindset of, if it's not doing anything, you probably need to hit cycle start again. But you can do that from here. You can set your axis 0, so you can put it on any axis and 0 out. You've got 4 programmable macros on here, and this is the for me, I would like to have many on here, and I wish there was a way to like menutize these or something, but you get 4. The cool thing for people who don't want to program their own stuff is these are what you assign to these 4 that are there. There's really a big choice in the wizard, so you get to set that up in the wizard when you're configuring the system and say, well, I want this to do a Z up, for example. I don't remember which one I had on here, but one moves it all the way up. Yeah, I have that one for to go to Z0. You can do, you know, touch plate work. You can literally remap these to anything you want if you want, or like I said, there's a big choice in the wizard for what you want to assign to it. Every one of these little clicks is an incremental thing, so you could just crank away if you really want to move it, but you've got these tactile clicks that make it incremental. So I can quickly go from 1/1000th of an inch to 10/1000ths to 1/10th of an inch. So there's nothing special about this compared to like all the other pendants you've seen out there, other than this is built very well. It's got a magnetic back, so you can stick it on the side of your machine. Stick right up there. It's very responsive. It comes with a long range antenna. I think that's good for up to 300 feet or something like that. It's very well built. It's got this rubber outside, so you know if you drop it, it's not going to break on you. So very well built. I would say, you know, it's easily worth the $300 from a quality standpoint and everything. I'm not at all hesitant to say that. You know, with some people say they've had problems with the keyboards being not reliable. I've never had that problem, but after I've used this now for almost 2 weeks, I can say it's for those who didn't like pendants like me before compared to the keyboard. I'm fine with using this now. Like I said, I still would like to have more macro choices on here, but that's just the way it is. So I'll get used to it. All right, I don't know how well this is going to come through on the camera. I don't have my OBS studio installed on this computer to actually screenshot video, so we're just going to take a video of it. But I wanted to do a quick overlay or overview of this. So this is CNC12, this square here, and this is what they call the virtual control panel. They're actually, I don't know all the history of Centroid, but if I look at this, my guess is that this panel on the right, this is actually minimizable. You can make it go away. I would guess that this used to be a physical hard panel on their CNC controllers, and this was probably like, you know, an old school LCD, or even at one point maybe a CRT screen that was, you know, like the old RGB or just some really monochrome monitor kind of thing. This is really output only probably at that time. And so as they've modernized it, they've made this panel over here much better looking. They've virtualized it so it can run on a PC, but it's really it's a separate application. It can be minimized out of there. The other thing with this is it's completely user configurable. It's not as nice as Mach 4. Mach 4 had a very nice screen editor that you could do a ton of stuff with. This is a little bit more limited, but almost most of the stuff you see here is actually customized by AVID, and they did a really nice job of tuning this in for router use, including CNC, including laser and plasma cutters as well. But you can go in here and edit this to your heart's desire too. It's basically, it's laid out in a grid of columns and rows, and like you can adjust these, make your own graphics, you can make your own macros that they call, do all that kind of stuff. What's less user modifiable is everything over here. This is basically, I'm not positive, but I'm guessing this is like a C application or something running on this computer, and it's tightly coupled through Ethernet down to the Acorn board. But it has all the same basic features. You got a area where errors and FYI comments, you can see aborts or job done, just different comments come out here. That's kind of like the history window in Mach 4. You got some basic things about what your file name is that's loaded, which tool you're running, your feed rate overrides, stuff like that, your execution time of your file. You got a big, huge DRO readout here, and then down here is your snippet of G code that runs, and then your machine coordinates are down here, whereas your work coordinates are up there. And then and that stuff is fairly static. And then down in this bottom section, you have a menu area. So this is where you can go down deep, multiple levels. And so all of your settings are down in here. So in Mach 4, you had a bunch of pull down menus for configuration, but most of the runtime stuff was up on the main screen, whereas on Centroid, a lot more of the runtime stuff is down in these menus that you got to get, but they're pretty quick to get to once you figure it out. So for example, if I want to set part zeros, I click this button, and now I get a whole new menu down here. So I can set my coordinates manually. I can set them for a laser offset. I can use a probe. I could use a plate. So for example, if I want to use the touch plate, I go to the plate thing here, and now you can see this is the menu for using the AVID's touch plate. And like, for example, I can click around, go between inside and outside, or I can go select different corners that I want to place it in. So all those things that you're used to in the AVID, I guess, utilities for things like that are there. It's got a real nice indicator here that actually goes up and down when you trigger. If I go back a menu level, we've got probes, so you can one of the nice things here is that they've got a lot more features built in. So when I first found out about AVID's conversion, I was in the process of writing a really big probing tool for it, because Mach 4 didn't I didn't really like the one Mach 4 had. It was kind of limited. The AVID probe one was very much just for the plate, but all of these other things where you can probe a bore or the outside of a boss or a slot, inside corners, you know, this is all made for a touch probe. None of that was really there. So I was writing that, and then when I found out Avid was converting, I was a little sad, to be honest, because I had just really gotten used to programming this kind of stuff with Lua and the API set that was in Mach 4. But then when I started digging into this, I'm like, well, man, this has almost all these features here already, so you don't really need to do as much. So you got all that kind of stuff. You can actually find angles, all of that kind of stuff. And then you still have like your manual set XY or set 0. You can manually just click on one of these and go down here and set it. So a lot of that's, you know, all the normal stuff you do, it's all here. Loading jobs, you know, pulls up a dialog where you can pick your files. It's got a whole ATC section for doing tool heights. One of the really cool things is smoothing here. So Mach 4, as I mentioned, basically the only adjustments you had for how smooth something would run is you could slow it down so your feed rates affected it, and you could detune or dial in the acceleration values. Well, check this out. If I go to 3D fine relief, so basically they put in the infrastructure here so that you can have a different set of parameters tuned for different kinds of operations. So like if you're doing, say, precision router, you're just cutting out a part that's squares and circles and it's got to be super accurate, and you're probably going to run really slow with it anyway. They've got this precision router. If you are doing contouring, so maybe you're using the router to do shaping of a large 3D surface, and some of those things make these funky kind of steps in it. You know, they don't do a big round arc very smoothly. They've got a configuration to smooth that out. They've got one for V-carve where it optimizes the speed versus not getting too much vibration when it does those sudden stops in the corners. And then 3D fine relief is for like doing 3D relief carving. So these are all fine-tuned, but let's just take a look at that. You can go in here and customize these. And now instead of just acceleration, we've got all of these parameters in here. S-curve, minimum angle, step size, the number of points when it does smoothing around a corner and rounds it. Mach 4 had a constant velocity mode where you could tune that just a bit, but honestly, it was one thing was it wasn't documented at all. This one is documented very well, but it kept changing on the last few releases from what I could see, and I had a hard time really getting it to work consistently. Whereas this you can play with, and it does the same thing on every release. Your acceleration multiplier here is set to 1. But on this other preset, you can set it set to 0.3. So you can slow it down. You can reduce your acceleration. You can increase it. You can do all these kinds of things. And you'll see in the performance data that I have, this really works well. So you can spend days fine-tuning these if you want. But Centroid has done a great job. And I actually deleted a couple that were over here for milling because there's Centroid and they have Acorn, they have Acorn 6, they have Oak, Hickory. They've got all these different boards they make. Acorn is kind of the smaller 4-axis version, more for routers and stuff like that. I deleted a couple of these, but you can have up to 99 of these and up to I think 8 of them or something on the screen here. So you just simply select it and it applies it as it's running. So you don't have to go in and change all those parameters directly. You can fine tune them, dial it in, and then save it as a set and then call it up wherever you want. You can also call it up through macros in your software. So you can say, you could make a post processor that always, that was always for 3D carving, that always called up this if you really wanted to. So I'm not going to go through much more on this, but that's kind of the high level. one, probably my biggest complaint about Centroid is this, it uses the screen space very inefficiently. It's much better than it was. Again, I'm not an expert about their history, but if I go back and look at some of their previous things from a few years ago, they made huge improvements with this. But in my opinion, they should probably double the grid size in this so we can have smaller icons. I mean, this is a 27-inch monitor. I could do with these icons all being half the size or a quarter of the size that they are and still read them easily. So, and then over here, you've got graphing, for example, like Mach 4 does, but it takes up the whole screen. I really would, and you have to toggle, do you want graphing? When you're running, you're going between graphing or seeing the G code. I really want to see the G code and the graph and the alarms and all this runtime stuff at the same time when it's running. But right now you can't, because you look at these fonts, right? They're huge. This could all be in a tiny little square. So I'm hoping in the future, and I'm sure they're going to be improving this a lot in the future, because they just released a new version of the software that AVID is moving to in the next month or so, I think, that really updated the graph capability. So I'm thinking, I'm hoping that they're going to make some improvements on just the runtime visibility of more and more of the features. The features are all there. They're just, like I said, they're just not all visible at the same time, and it would be really nice to be able to see those at once. Again, down this section here shows all the active codes, so your persistent codes that are active at a time are displayed. So it does all the same things. They're just laid out a little bit differently and everything. All right, let's talk about the software itself. The software installs itself pretty much exactly like Mach 4 did, which is to say it doesn't put its tentacles into Windows at all. So when it installs, it goes into this CNC directory for a router, whereas Mach 4 went into the Mach 4 hobby directory. That directory completely contains the operating, or CNC12 essentially. So you can make a copy of that, make a backup copy. You can have multiple copies of this and just rename them back to CNCM when you want to run that one. The other thing is it's got a very capable, I can pop it up here, profile manager, where you can have many different profiles with different versions and just simply start that one. So you don't actually have to rename these. You can have multiple directories, multiple revisions active, and just select one to run it. But you can also make CNCM_backup, and so when you start making edits to everything, you can keep that backup in case something gets hosed up and you can't get back to that point. You can just reinstate the backup. So if we go into that, it's similar to Mach 4. It's got all your runtime files, your setups, and your macros and everything. There's a couple of kind of differences to think about. One is that Centroid documents the crap out of everything. It's awesome. I just got done reading their new router user manual. It's 500 pages long. It has every single user variable in the system variables. It goes through every single macro. It's got a macro programming guide in it, a smoothing guide in it. I mean, it's very detailed. It's excellent. So, if you're used to Mach 4, they don't believe in documentation too much. This one is the complete opposite. So there's that. And then I wanted to point out the programming, I guess, language is, everything is called a macro in CNC12. So for example, here's the standard set of user macros. It's going from M3, which is your macro to turn on the spindle, all the way up to 89 here. And so some of these are kind of industry standards: M3, M4, M5, M6, for example. It comes with a default macro functionality that's basic, but then you can edit it yourself. And there's a lot of them in here. So AVID has done a lot of tuning to make this an AVID flavor, and they've done some cool things that I'm going to point out. But the other thing I wanted to show is if you've done any Lua programming in Mach 4, they had a full API set. So it was more like a normal machine control API that you would see, a little more standard software system. So they created a full API manual that had all these things. So if you wanted to find out your X and Y coordinates, there was an API to go read out the current coordinates. If you wanted to set them, there was one to set them, etc. What's really different about Centroid is instead of all these APIs that you gotta go learn and figure out how to use, they simply give you the whole list of variables that all that data is stored in anyway. I mean, even in Mach 4, all of that information is in some register somewhere, some variable location, and all that API is doing is accessing it. So on Centroid, they just said, well, here's the variable list, and then they give you a few commands to go access them. So here's a M95. So they've expanded the M codes in Centroid. So there's a lot of proprietary M codes that do specific things. So you can kind of think of them as an API, but there's many less of them because, to be honest, most of it is just accessing and reading and writing variables. So some of these do specific other things too, but in this case, this macro is just turning off output 3. So this is the syntax for it, the M95, and then the 63 gives it the specific number. But I would say it's a little simpler. But the other cool thing is in Mach 4 macros and different software functions they were limited in scope. You had screen, you had a whole API set for the screen, but the screen set couldn't be run in like an M code macro. So they all had their own domains where they would work, and it was difficult to jump domains. You had to use something called registers to pass data back and forth in some cases, whereas in Centroid, it's really cool. A macro just really means software, and it doesn't care where it is, really. So you can call a macro fire laser, or you can call a macro M6, whatever you want. And other macros can call other macros, and you can load a macro just like a G-code file. So for example, the other day, I wanted to make a macro that would deploy my laser down and fire it in a low power test mode so I could fine tune my focusing. I took another macro that I knew deployed the laser and it did some other stuff. And in like 10 minutes, I could figure out what it was doing and hack it and make a new one. And I didn't have to go install it and get a button on the screen to fire it or anything, or go into a debugger. I simply loaded it just like any G-code file back here with a load job, and it wasn't a G-code file that moved things and cut anything. It was just macro code to deploy my laser and turn it on. So that it's a lot simpler, I think, for the average guy. You don't have to be a software engineer. I'm not a software engineer. I'm a hardware engineer, and getting to know Mach 4 took me a long time. I've only been playing with this a week and a half, and I pretty much understand how the whole software is laid out and stuff. There's a ton of detail behind it, obviously, I need to work on, but I mean, getting it from a high level is really simple here. It's a much simpler system. I think it's made for machinists to be able to still edit things, and you don't have to be a software engineer. So that's really cool. All right, I wanted to talk about the wizard just a little bit because I mentioned it before. Just like AVID had a configuration tool that was in Mach 4, basically it was a custom one they have. They've also done one in CNC12, but it's akin, or it's I should say part of the wizard tool that's already in Acorn. So this is the AVID CNC one, but I can go over and go into the default one that is there for CNC12, and it has more information in it basically this is kind of where a DIY person who is building their own machine would go in here and they would, configure their axis, their spindle, and all this. Whereas if you go over to the Avid one, whoops, they've parsed this down and made it specific to the machines that they build, right? So instead of having to set everything up, every little IO and everything, they've said, okay, well, just like the other wizard, here's your choice of sizes. You've got your size of your machine and stuff like that. Your motor stuff is pretty much set up based on your selections there. Then you can go to cutting tools and say, well, which spindle do I have? I've already configured this. So it makes it simpler, but you can still go to the detailed one and make tweaks if you want to do something custom. So they've got all the things. They've got laser, rotary. They're supporting a probe, which I don't know if Avid is selling it yet, but Centroid does, and I know Avid's going to be offering it pretty soon. I've got my own probe, so I'm going to hook this in. They're pretty handy. This is the standard touch plate information. This is the Avid one, but they also support custom ones, so you can get your own touch plate and do that. And then your MPG setup. This is what I was talking about. Is you get this whole list of items that you could put in here, or a custom one. So it's pretty nice. So that's it. I think I've covered all the basics. Again, this wasn't meant to be a how to run it or anything video, but I just wanted to kind of give a background overview of the differences. But if you're used to running Mach 4, what's different about this? I think I haven't seen. There's nothing I could do in Mach 4 I can't do in here. This is more capable, I would say. It's got way more features built into it, much more tunability, things like that. Again, the user interface would be the only thing I would say is not quite as convenient, just because it doesn't show me as much stuff all at the same time. But again, I truly believe they'll improve that in the future. The other thing I'll say about this is I've been using it a week and a half now, and it has yet to do something where I said, why did it do that? Like stop in the middle of a G-code file, or plunge too deep, or just, Mach 4 did that every once in a while. And some people had very frequent episodes of that. And that's why I didn't really have that big a problem with it with Mach 4, but I know some people were just infuriated with Mach 4 because it would do that to them all the time, and they would ruin jobs and stuff like that. So again, I think that's probably the main reason why Avid had to switch, is just that they had some systems that were so out in the field that were so unreliable, and sure, I'm sure some of it had to do with the computer setups and stuff like that. But, honestly, if you have a system that's so particular about the computer that everything's running on, then it's probably not a reliable system. And, this should address that, I think, at least from what I've seen. It's been rock solid for me. I haven't had any issues other than a couple weird things. And then I realized, I just didn't know what I was doing. It was user error. And once I understood how things worked, I didn't have that anymore. So I'm pretty happy with, from a high level, the functionality and the software, the box. It's a really nice hardware. I think what Avid did on top of Centroid is really cool. They've got a really nice set of useful menus, like the utilities. Like, here's your manual tool change, you got your home. These are all nice big buttons you can find. Really, you got a utilities menu here for doing some of your calibration. So I talked about like the offset calibration between the touch plate and the spoil board. That's stuff in there. You got a spindle warm up, all your jogging controls here. There's a park button, so like at the end of the day, if you want to have it park right up by your homing, well, you can program the park locations in the wizard, so you can have it park in the back if you want, out of the way, or have it park right by close to machine zero, so that the next day when you power the machine up in home,
It's very close by, and homing doesn't take long. The other thing I want to mention is with how the system remembers where it's at. I've noticed that, you know, if you restarted Mach 4, you had to rehome. This thing always remembers its coordinates. The only time you have to rehome is if you've powered down the box or you've lost steps. Like I did, I jammed my Z-axis down into the workpiece once with the pendant, and I lost some steps, and it needed to be rehomed. But other than that, you can you can restart Centroid or CNC12 as many times as you want, and because you everything's stored down in the computer on the Acorn board, it still has everything. It's not really, you know, restarting that piece. It's more restarting the stuff on up on the PC. Um, so it's much more convenient that way, I guess I should say. You're not, I'm not rehoming nearly as much as I used to um, on Mach 4. So that's also been a pleasant surprise.
Well, I tried to make some good quantitative tests for two aspects of the performance. One was the vibration, and the second one is the execution time, because those are usually kind of always a trade off. In Mach 4, you could always run it a little slower, and then in feed rate. However, the most effective thing for controlling vibration was dialing down the acceleration value. And that was absolutely necessary if you really wanted clean laser work or good V carving where there wasn't any chatter on the sides. If you're just cutting out big panels of plywood, it doesn't really matter. You can just run at high acceleration values. So that always comes with a downside of, if you know, V carves have very short vectors, 3D carves have very short rep vectors, and a lot of laser work has short vectors. So you're always starting and stopping, which means you're kind of always in the acceleration zone. So the acceleration setting can have a huge impact on your execution time. So it's always trading off speed for smoothness, basically. And the EX controller, I'm sure, is no exception to that. So I have basically three tests I've done here. One was the text. It was, I call it good vibrations, but it's basically a G code file with a large block of text that I generated in VCarve, but very small font characters, so it creates a lot of very quick, short movements. With that, I actually just turned the laser off, but ran it as a laser job, so it was using my normal settings in Mach 4 that I use for lasering. On the EX system, it was using the laser, I call it laser smoothing, but basically it's got a default set of parameters for laser work that it turns on. I need to dig into that more because I can't see where it's configurable yet, so I don't know what those parameters are. They're not visible to me like the regular smoothing settings are. But regardless, that works pretty good. But we're going to be comparing that. The second thing is a 3D carve here, and that I just took a small slice of a 3D carve that I had. It's a 3D carving of the Last Supper, and I took a slice out of it where it has some very deep, rapid plunge moves as it rasters across the workpiece. Again, trying to see how smooth it runs there. But this is a coordination between X, Y, and Z, whereas the vibrations test, the good vibrations, is just X and Y because it's laser work, so it's Z is constant. So the 3D carve does 3D, the good vibration does 2D. And then the third thing is what I called shapes. Basically, this is a vector file that looks like this. It's doing 3 layers of star, circles, squares, and an oval shape. And I picked this. This is actually burning the laser. So in this case, I'm not measuring the vibrations with an accelerometer or anything, or a glass of port. I'm just simply looking at the quality of the lines. And this is probably the most accurate way to see the vibrations, because it's really all that matters is what's the quality of the cut or the laser burn. And so you can see it directly in this. So we're going to use that and compare Mach 4 and that. And then between those, again, I said it's trade-off in execution time. So I also measured how long did it take for each one of these G-code files to complete. And that's what this column is. So what I try to do is, on the shapes one, we're just going to look at the pictures in a minute. So these are blanked out because I'm not measuring magnitude. And then on the magnitude, I use the vibration accelerometer. It's an accelerometer-based vibration app on my cell phone. I don't even know what those units are. Again, this is not a exact measurement. It's more of a comparison just to say, well, is this better or not? And hopefully, you would hope that better vibration probably tracks with longer execution time, because again, it's really just physics and there's not a ton you can do there. You generally have to slow down a little bit to get better vibration performance, but maybe not, because in the EX there's a lot more things than just pure acceleration. You've got nonlinear acceleration where you can turn on S curves. You can affect just the one parameters for acceleration, but then there's a whole bunch of other things you can mess with. So the idea here is to try and quantify this as much as possible. So if we look at, let's just look at the execution times here first. When it says laser smooth over here for the EX, that's just running this straight out as the laser smoothing. When it's burning a laser job, it's just using that one set of parameters. However, when I do a 3D carve, that's a spindle. That's not a laser job. That's running the spindle. In that case, I've got a bunch of different selections that I can use for different types of things. They have a V-carve one in there. They're basically presets that they've kind of fine-tuned and optimized for these kinds of things. So I chose the 3D relief carving parameter set as one that was probably designed ideally for 3D carving like this. And then I took the exact stop mode one, which doesn't do any smoothing, but I don't know what else it does because it's also hidden. It doesn't show me what the parameters are, but I was assuming this would be the roughest and the fastest one. So I kind of picked those two to look at for the 3D carve. And then on the Mach 4, I started out with constant velocity mode turned on, but it turns out that I saw some pretty bad rounding at the lower acceleration rate. So for the rest of the tests, I just turned that constant velocity mode off and I ran exact stop mode. But I did it at two different acceleration settings. 50 inches per second squared is the default setting that AVID ships the machines at. I found that it's way too high for lasers and V-carving. And then 15 is generally the number that I use for lasering and V-carving. So you can see straight up here that, say, even in exact stop mode, the acceleration from 15 to 50 makes a pretty sizable difference here. It slows it down quite a bit across the board here. So then when you compare constant velocity at 50 at the higher acceleration to exact stop at this lower acceleration, you can see that kind of they average each other out, because constant velocity mode basically chops up a corner into a whole bunch of little pieces. So now it has to start and stop on a bunch more segments as it's going around a corner. And so constant velocity slows it down, and these two end up being the same. This one's slow because of the acceleration. This one's slow because of the constant velocity. And then this one's very slow because both the constant velocity and the acceleration are hitting it. So if we compare these, the laser smoothing is actually a little bit slower than even the constant velocity at slow speed. So they have kind of tuned the laser smoothing to be very good, but it's also not very fast. So in the future, I'll be looking at that to see if it can be sped up without sacrificing the speed too much, or without sacrificing the vibration performance. But we'll look at this in a minute. You'll see that this is actually a very good performance-wise as far as vibrations. Then on the good vibrations tests, you see that again, you see the effect here on the Mach 4 time, where I'm running exact stop mode only here, but the acceleration itself makes a very sizable difference here. The vibration magnitude is also improved. The range at the very slow speed, the bottom end of the range is about the same, but the peak magnitude of vibration is much, much lower here. It's only 3.5, whereas it's on 6. When I ran this test at 50 inches per second squared, it actually vibrates my workbench that is sitting on my concrete floor. So my CNC shakes my garage floor enough to actually shake my workbench. So this is a very, this one here is a very heavy vibration for sure. I never run it in that mode. Then over here you can see when I run that with the laser smoothing mode, it is faster significantly than the exact stop at 15, and it's in exact stop mode it's a lot faster, yet it's twice as fast as the laser parameters were. So again, these parameters kind of track the same way Mach 4 works. Is the less smoothing optimization you do, the faster it runs, but the lower the performance is. Over here, I just so you can see for example, the magnitude of the slow. This is kind of the slow performance mode, or where you get good smoothing. It's on the order of or better than the exact stop mode. So I would say in general, this laser smoothing mode has lower vibration, and we'll see that in the laser pictures too. And it's fortunately for these particular things, it's faster. So one of the difference to think about on this test for the shapes is there's not that many vectors. It's there's some basic geometric shapes, and they're either arcs or some straight lines, but a couple dozen vectors maybe, whereas this one has I think it was 230,000 G-code lines. It's a very long file with tons and tons of things. So the smoothing optimization actually comes out here, where up here, where on those particular vectors, this short number of vectors, this was actually a little bit slower than this. It's actually faster and smoother here. On the 3D carve, it's really amazing. So the 3D carve again is all 3 axes is moving. I'm running over here exact stop with the slowest acceleration. It's 26 seconds. With the 3D relief optimization setting, it's literally less than half. It's like 40% of the execution time, and it's running slightly smoother. So that 2 to 3.5 is kind of the range of the magnitude of the vibration on the meter, where it's only 2 to 3 here. So that is huge. You're talking about taking a 20-hour job down to maybe 8 hours or something, if you're doing a really big relief carving. So you're getting as good as or better vibration performance. So you should get just as good of a smooth cut in 40% of the execution time. That's a big deal. Then if I ran exact stop mode, I saw the same thing. It's in this case, the exact stop, it's better vibration, but exact stop here compared to exact stop here is kind of the same thing, so it's about in the same ballpark because it's not optimized like this 3D relief. So I really want to go try this 3D relief out in the future and actually kind of gauge the smoothness of the cuts themselves, because of the vibrations, I do expect them to be better. This will allow you to run like maybe a smaller step over or something to get a smoother cut yet, and still not exceed the execution time that it would have been under Mach 4. So now let's look at some of the actual pictures of the physical cuts, because this is pretty telling, I think. So over on the left are my 3 runs of this under Mach 4. So this first one is 50 inches per second with constant velocity mode on. You can see if I zoom in, ovals can't run. They have to have all these tiny little segments in this part here, because an oval, it's an ellipse. You can't use a straight line or an arc for very far, whereas all of these, the squares, the stars, those are all just, each one of these lines is just a straight line, a single vector. So any squiggling there is just due to when it bangs around a corner. Circles are really easy because they're just arcs. So a circle can be done in 4 arc moves. So they're pretty smooth to start with here, and they're not slamming around corners. So almost all conditions, circles are ideal. But you see a little bit of vibration here when the direction changes, 90 degrees. But what I found is that ovals are really telling with the laser because of all these tiny little segments of vectors that have to be executed, and they're not smoothed out very good in Mach 4. So this was constant velocity, 50 inches per second. This one here, I slowed this one down as constant velocity is on, and I ran down to 15 inches per second, or inches per second squared, I should say, acceleration, not feed rate. So again, the circles are clean, but now a lot of the vibration is gone because it's a very slow transition for every one of these vectors. So it cleans up, the oval here is pretty smooth. There's not much vibration on here, but you can see the constant velocity kicking in here. These corners are very rounded on the inside on the star, and the square has very rounded corners. This means that my constant velocity data table in Mach 4 isn't really set up ideal. And this used to work just fine. And this is one of the problems I've seen with Mach 4 is they mess around with some of this stuff from release to release and don't necessarily tell anybody. So I've noticed changes on some of the recent releases where I have to go back and optimize that table. You can tell it's constant velocity because where it starts and stops is perfectly square on these 3 corners. But then the rest of these are round where it flies around the corner. So now this one up here is exact stop mode. Just go up a bit so you can see the title. This is exact stop mode, but at the slow rate. And so at the slow rate with exact stop, constant velocity is turned off, and you can see the corners all turn square again on both of these features that were rounded over here. However, all these squiggles came back because now there's no rounding in these little transitions. So when you're running down here, and in here, the constant velocity is breaking up those sharp corners into smaller moves, and that's what constant velocity does to reduce vibration. And so you can, if you turn constant velocity off, then you only have the effect of acceleration. I did not run 50 inches per second in exact stop mode because that would be just scary how ugly this would be. There'd be just monstrous wiggles in here, and these corners would be horrible in the squares, so it's not even worth looking at those. So keep those in mind. Now let's slide over here to the ES controller, and I'll go up a little bit here so we can see both of these side by side. So all of these have nice clean corners like you'd want. There's no rounding. There's also hardly any vibration to speak of. I mean, look at, there's a little bit of ripple you can see down here. But this is like the cleanest. There's nothing over here that's that smooth other than the really slow CV plus 15 inches per second right here. The magnitude of that is about the same as the magnitude of this. However, this is making like perfectly square corners and no vibrations, just, you know, or little ripples where you see it changing direction. So this is like the cleanest laser lines you can really expect. Keep in mind, this laser is a 2/1000th of an inch wide beam, so this is less than a sheet of paper wide. These are all pictures I took under 30x magnification. That's how small these features are. So these are extremely clean. The laser smoothing mode does, there is a cost penalty on these particular shapes, as I mentioned, and when we went over the table. This one's about 15% slower to run the whole file. However, this laser smoothing setting is actually faster than constant velocity mode for, as we showed, for the vibration test. So you win some, you lose some. You do definitely any optimization you do kind of needs to go with what exactly you're doing, and that's what's nice about Centroid is they've given you all the parameters to dial in, but they've also made it easy to make sets of those. So you can, you could have milling ones, you can have precision ones, you can have, precision one where you might want to really accurately machine something and you're willing to take a penalty in execution time. And then some of them are optimized for laser type movements with larger vectors and laser type movements with small vectors. So you can make all of these, dial them in, save them, and then you can just select them when you're going to go run the file. So it's very easy to switch back and forth between these optimized sets. And as I said, Centroid has done a good job of kind of picking out, the typical modes of operation, like 3D carving versus V carving versus precision milling versus like doing big contoured surfaces. So they've created them for people. So if you don't want to mess with it, you don't really have to. I've tested these out, and they did a really good job of optimization, I think. So that's the performance side of this. So I can definitely say that you have much more control over this tuning. You can get as good as or better results. Across the board, you can get as good as results. And then for the most part, I'm seeing better performance when you take into account both the execution time and the actual vibration control. So their smoothing parameters and capabilities, I would say, are pretty superior to what you can do in Mach 4. Again, that really you just had to slow it down and turn down the acceleration, where, as I showed in the table before, there's about 8 or 10 parameters that are all related to smoothing that you can dial in for your specific cases. Okay, here's a quick side-by-side comparison of Mach 4 running 15 inches per second squared acceleration versus the CNC12 software on the right, running the standard laser smoothing parameters. The best gauge probably for the smoothness is the vibration or the ripples in the port in the glass. But you can also see the numbers that are coming across on the accelerometer. This is the vibrations test, which is the fine text running on here. So it's just an X, Y direction, no Z action on this. All right, here is the Mach 4 running at 15 inches per second squared on the left, doing a 3D relief carving, and on the right, the same exact G-code file on CNC12, running the 3D fine relief smoothing setting. And I think, again, from the glass support and the vibration meters on the phone, you can see that the CNC12 is again running a little smoother. So apologize, this was kind of a long-winded video. There's a lot of things to cover, but I think in summary, the Centroid Acorn and the CNC12 with just the stepper motors that I had pretty far exceeded my expectations as far as vibration. In all cases, it was at least as good, even compared to where I really had slowed down Mach 4. But not only was it did it have lower vibration in all cases, in some cases it had significantly faster runtime for the file as well, and that to me is equally important. So I didn't spend a lot of time tuning. I mostly just used the canned settings that Centroid had in here, because my goal was to kind of knock this out quick just to see how good is this with just the steppers. My end goal then is really to go to the servos now and see how good it can be with the controller and the servos, and I'll spend more time there. But in general, this works well. I've got, both the spindle and the laser working. I've done a few jobs with this now before I tore it apart again to put the servos on. One thing I didn't talk about that I'm going to go into in a lot more later is I did a couple of laser picture jobs where they're basically rastering, but not like Mach 4, or actually I should say ESS. ESS has a native rastering capability on the fly, scanning back and forth. It doesn't do it with G-code. It does it with, it actually loads the bitmap image into memory and scans it across it, and it's very good. I ran one of these G-code rasters that I generated in VCarve with the laser module, and it ran amazingly smooth. I couldn't even believe it. Mach 4 would just choke on that when running it over about 50 inches per minute. It would just start shaking, and it would have misalignments between the left and right passes and everything. It just really couldn't. I don't know if it was the trajectory plan or what, but just couldn't handle G-code running, pixel-sized starts and stops. When I ran it on Centroid, it was just like it was loaded into memory down on the controller and scanning across there. And maybe that's actually how they do it. I have no idea how they actually achieve it, but I can't believe how smooth it is. So I'm really looking forward to doing a bunch of laser testing in the future, but I'm going to save that for later until I get the whole servo system up and running smoothly, and I'll actually dedicate some of the I'll dedicate some of the testing to specific laser videos in that case. So anyway, so for those who are curious of, if they don't want to spend the money on servos, is this controller worth it just to put on to replace your Mach 4 setup? For me, I could say yes. It is a lot of money, but Avid's giving pretty good trade-ins, I believe, for your old one too. But I'm really pleased with Centroid overall. It's got, if you don't want to mess with software and you just want something that works, it's got it for that kind of person. But you also have all the bells and whistles and hooks in there if you want to go in and write your own software and customize everything for yourself. It's also got that. So I think it's a very good overall system for everybody. Obviously, the performance is really good, and so I'm real happy with it. If you have any questions, feel free to throw them down in the comments, and we can talk about them. Thank you.